so let's get into it. Tonight I wanted to do a little bit more calculus with you, and then on Thursday evening I'm going to do some more paper 2 work with you guys as well. All right, so as always, these questions come out of final NSC exams, and this particular year they gave the students the graph of g of x, which equals x cubed plus bx squared plus cx plus d. Which is sketched below there. We can see it over there. And they're telling us that the graph of G intersects the x-axis at -5 and at P, and the y-axis at 0 and 20. And then they also tell us that P and R are the turning points of G. Okay, so in 9.1.1, they want us to show that B is 1, C is -16, and D is 20. So they set it out like that so that if you can't solve for B, C, and D, you've still got the answers in order to be able to do the rest of the questions. So don't just leave everything out if you can't do the first one. Use the information that they've given you in order to be able to get the rest of the marks, because you don't want to go and throw everything away just because of one particular question. All right, so the B, the C, and the D that they're asking us to prove are 1, -16, and 20 are the B, C, and D that are in the equation up here. Before we get started on this question, I would just like to make mention of the fact that all cubic functions have the same general form. All right, so in this case, we've got y equals, well, in every case for every cubic, we've got ax cubed plus bx squared plus cx plus d. What are they telling us about the graph with regard to the letters here? They've told us what one of the letters is and haven't asked us to solve for it. Which letter and what's its value? Based on the information that's provided, what have they told us? They've given us the y-intercept, absolutely. Okay, so when we see this over here, we know that that's the y-intercept, 100%. Good, well done. So they've told us straight away that D is equal to 20. They've also told us the value of another letter, not the B or the C, but the A. What are they implying about the A? What is A equal to? That's it, Kalipa, quite right. Okay, so they are implying as well that A is equal to +1. And remember, A affects the shape of the cubic function. When that A value is positive, the graph is concave down and then concave up like this one. And if that A value is negative, then the graph is concave up and then concave down. All right, so that's also important. They've told us that the value of A is equal to 1 in this case. All right, so now we need to set about proving that B is 1, C is -16, and that D is equal to 20. How are we going to do this? Any ideas on what I should do? Can anyone make any suggestions to help me, please? What would we sub into?
You can unmute and tell us, or you can put it in the
Absolutely, you
chats.
can unmute and put it in the chat. Exactly. So we've got to write it using the roots. You're quite right, Cheslin. So what Cheslin is saying is this, okay? We've got to write it like this. Y equals A, x minus x1, x minus x2, x minus x3. But we need to adapt this a little bit to the situation that we see below us, all right? So this is the correct form, but how am I going to change it so that it suits exactly what I see? Because I don't have 3 distinct roots. I've got 2 roots. And one of my roots is also a turning point. So how can I modify what I've written in 9.1.1 to suit the situation I see in front of me? In other words, what do I do when I have an x-intercept that's also a turning point and I want to write root form? What do I do? That's it, Segofatso. Okay, so the root, that is the turning point, and the x-intercept has to be squared. You're quite right. So I'd say y equals a, x minus x1, and then here I'd have x minus x2, and that would need to be squared. Okay, so that is actually the correct thing to write in this case. Okay, so the bracket that is squared, that is where, remove the last bracket, that's it, well done. And it doesn't matter whether I square the first bracket or the second bracket. What's important is that the root, where it is the turning point and the x-intercept, goes into that particular bracket, right? Do I know the value of a? Yes, I know that it's equal to 1 because they've told me that. So I've essentially got y equals 1 into x minus x1, x minus x2 squared. So what do I sub in next? What do I sub in next? The y-intercept, okay, all right. So when y is 20, these will be equal to, this x over here will be 0, and this x over here will also be 0. So if I sub in the y-intercept, I get that. What else can I sub in? Yes, Ayanda. Yes, Lebogang. I need to sub in my x-intercept over here, right? This x-intercept, I don't know, but let me call it p. It doesn't matter. I can call it anything I want to. I'm just not going to call it x or y, right? So now I'm going to say 20 is equal to 0 minus negative 5. So that will become plus 5. And then here I've got 0 minus whatever that p value is going to be. So I'm just going to leave it and I'm going to call it p. So now that I've got this, what can I solve for? If I solve this equation, what am I calculating? What does P represent? Yeah, so P represents the x-intercept, the other unknown x-intercept. Okay, so I can work out what it is. All right, so if I go ahead and go and do that, I get 20 is equal to 0 minus p squared, means that p is squared, and then it's got to be multiplied by 5. So I'd end up with 5p squared. Yes, my second x-intercept, that's quite right. Divide both sides by 5, and p squared would be equal to 4. So that means that p is going to be equal to plus minus the square root of 4. So now, is p equal to 2 or is p equal to negative 2? P is equal to 2. All right, it's equal to positive 2. Okay, good, well done. Now that I've worked out what p is equal to, remember, I'm still trying to show that b is 1, c is minus 16, and d is 20. So what am I going to do now? I've got to go and sub it back in, don't I? So I know that I've got y is equal to a is 1, all right? Then I've got x plus 5 times x minus 2 squared. Is everybody happy with that? Cool. And now I can multiply everything out and I'll be able to show that b is 1 and c is minus 16 and d is 20. Okay, so what I'm going to do is I'm going to leave my x plus 5 at the front. I'm going to square my binomial first. That would give me x squared minus 4x plus 4. And now I can multiply my binomial with my trinomial. So I'd end up with x cubed minus 4x squared plus 4x plus 5x squared minus 20x. Whoopsie, and I'm running out of space here. Let's just see if we can scooch over just a little bit. Create some more space. There we go. Where were we? Okay, 1, 2, 3, 4, 5. So we're on the last one, plus 20. Okay, so now collecting like terms together, our x cubed is going to remain unchanged. We've got minus 4x squared plus 5x squared, so that'll give us 1x squared. So there we go, our b is equal to 1. Plus 4x minus 20x gives us our minus 16x. And then we've got our 20. Okay, so therefore b is equal to 1, c is equal to negative 16, and d is equal to 20. All right, everybody happy with that? Are we all okay? Yes, good. Cool. So that was out of 4. So we would have to get a mark for subbing in. We would have to get a mark on P being equal to 2. Subbing it back in here and then multiplying everything out. We're not going to get a mark on our answer because all of that information was given to us. Okay. All right. So the next question, they want us to calculate the coordinates of P and R. Okay. Do we know what the coordinates at P are? We already know what they are, but they've asked us to calculate them as well. So P and R represent the turning points. So what do I do when I want to calculate the coordinates at the turning points? What do I do? I've got to derive, correct. I've got to use the first derivative. And of course, this graph was the graph of g of x. So the first derivative will be, let me just move that out the way, it will be g prime x. Okay, and that will end up being 3x squared plus 2x minus 16. And equate to 0. Yes, very important. So I've got to make sure that I make it equal to 0 because the gradient at the turning points is 0. And now I need to solve for x. So either I can factorize, or if my factorizing is not great, I can use the quadratic formula. Okay, remember, excuse me, when you use the quadratic formula, remember to show that you've subbed into it. Don't just write the formula on the page and then pick up your calculator and write down the answers because you're going to get penalized for that. So make sure that you've shown that you sub into the formula. If I decide that I'm going to factorize here, I now need to think of the factors of 16 that I could use in this particular case. So if I put 2 here and I put 8 over there, that would give me negative 6 plus 8 would give me the plus 2 in the middle. Okay, Gugu, do you know why it can't be 4 and 4? Because you already know that one of them has to be 2, don't you? Because remember, we worked out what the value of x was at P. We know that it's got to be 2. So we know that one of our brackets has to be x minus 2. Does that make sense to you, Gugu? Can't be 4. All right. So all your alternative here, use the quadratic formula, and then there's no worrying about is it 4 or is it 2 or is it 8 or is it whatever it might be. Okay, so either x is going to be equal to -8/3, or x is equal to 2. We knew about this answer. Okay, because we know that when a cubic function has its turning point on the x-axis, that point is going to be a x-intercept and it's going to be a turning point. So we knew that one of our answers had to be x is equal to 2. As far as our other answer is concerned, we were expecting a negative x value because r seems to be located in the second quadrant where x would be negative. So our answers make sense in terms of what we know. All right, now we need to go and calculate the y coordinates at these points. All right, so we already know that g of 2 is going to give us 0. So we know the coordinates at P are 2 and 0. Now we need to calculate g of -8/3. And because we're putting in a nasty fraction, we're expecting a nasty fraction out. Okay, so this is going to be -8/3 cubed plus -8/3 squared minus 16 into -8/3 plus 20. Let's just check that we've got that correct. There we go. All right, pop that baby into our calculators. And what are we getting as an answer, guys? It's okay. Mikhail, welcome. Okay. I didn't get 36. Yeah, I'm getting what you got, Ayanda. I'm getting 1372/27. Okay. 1372/27. All right, and we expect a revolting fraction like that because we put a revolting fraction in. Okay, so therefore the coordinates at R have to be -8/3 and this horrible number 1372/27. Okay, that seems reasonable. There we go. Thanks, Kalipa. Thanks, Ntokozo. Yes, maybe the others just pressed something funny. All right. The other thing I just want to encourage you to do, when they ask you for the coordinates of a point, make sure you write your answer using coordinates. Okay, because they can penalize on that. They won't penalize you every single time in every single question, but they could decide to penalize in one particular place and you don't want to lose any marks. Okay, so make sure if they ask for coordinates, you give them coordinates. If they ask you for the equation of a line, give them the equation of a line. So always finish your answer off properly before moving on. Okie doke. So this is out of 5 marks. This is supposed to be one of those sorts of accessible questions that everybody should be able to do. So definitely a mark on the derivative, definitely a mark on making the derivative equal to 0. They often give marks on factors. I'm thinking here, if it's out of 5, there would be a mark on P and then another mark here on R. Okay. Is everybody all right with question 9.1.2? Any questions? All good. All right, lovely. Excellent. Okay, and that's the sort of thing we expect them to ask us. Okay, so I'm just going to say before I move on, remember, a lot of matrics get confused with this. If they ask you to find the x-intercepts, you're going to make y equal to 0. If they ask you to find the coordinates at the turning points, you're going to make the first derivative equal to 0. Okay, so don't get caught out with that. Now they say to us, is the graph concave up or concave down at 0 and 20? So at the y-intercept, they want to know, is the graph concave up or concave down? Show all your calculations. So what should we do when they start talking about concavity? Matrix, what do we do? We're going to work out the second derivative, absolutely. So going from our first derivative, we've now got g prime prime x. We're going to derive again, and that's going to give us 6x plus 2. Derive twice, certainly. And again, just like the gradient at the turning points is 0, the measure of concavity at the point of inflection is 0. Okay, so again, we're going to make this equal to 0, and that's the reason why. And then this is going to allow us, absolutely, Cheslin, to calculate the value of the x, or the x value at the point of inflection. So this would be equal to 2. So dividing both sides by -6, we would get -1/3. So what we've worked out here is that x is equal to -1/3 at the point of inflection. Before the point of inflection, the graph is concave down. After the point of inflection, the graph is now concave up. So remember, at the point in question, x is equal to 0. So is the graph going to be concave up or concave down at that point? So what's happening when x is equal to 0? If the point of inflection is where x is equal to -1/3. That's it. Well done, guys. So therefore, at x equals 0, the graph is concave down. Okay. So Gugu, the point of inflection is at -1/3. So that's where the concavity changes. Okay, so before x equals -1/3. Sorry, no, it's not concave down, it's concave up. Guys, it's not, it's concave up. Sorry, just as I'm explaining it, I'm just suddenly realizing we're saying the wrong thing here. Okay, because 0 is bigger than -1/3. Okay, 0 is bigger than -1/3. So that's where the concavity changes. All right, so before -1/3, the graph is concave down. After -1/3, it's concave up. Okay, so at x equals 0, the graph is concave up, not concave down. Okay, does that make more sense now, Gugu? Sorry, I also just needed to look at it again. Everybody happy with that? Cool. That was out of 3. So there would have to be a mark on the second derivative and or making it equal to 0, solving for that, and then our explanation. Okay, so 0 is greater than -1/3. So the graph is concave up at the point 0 and 20. All right. Okay, so if that's all fine, let's go on and have a look at our next question. So the next thing that I thought we could do, I think we've already done 8.4 before, is question 8.3. So we're determining dy over dx. Do you guys want to do that by yourselves? Try that on your own, and then we can mark it together. Okay, cool. Off you go. And then you can just message Yolanda and I when you're done. You can just say done, and then we get an idea. Yeah, 8.3, Gugu, yeah. Awesome. Well done, Ntokozo and Tegofatso and Cheslin. So I'm going to start working through it quietly after you. Good, Mikhail. Okay, so I got the same second term as you, Joshua, but I got a different first term. Did the rest of you get what I got? Yes, okay. Yeah. Okay. All right. So this is out of 4 marks. Okay, so we had to remove the root and write it as 3/2, and we had to take that x into the numerator and change the sign. Okay, and then when we derived, we would get a mark on the first term and a mark on the second term. Again, pay attention to your notation when you were doing these. That's okay, Joshua. At least you know where you went wrong. Right, so remember, you are writing y equals until you are ready to apply the power rule. So it's only in the line where you apply the power rule are you going to write dy over dx. You're not going to write dy over dx the whole way down the page. Okay. All right. Cool. As long as you know where you went wrong, Cameron. I think we've done question 8.4 before, haven't we? Have we done 8.4 before?
Not this one.
Yeah, we have. I'm sure we've done this one. Because, yeah, I think so. I even remember one of the kids saying they'd done that exact same question at
Ntokozo says
school
we
or
have.
something like
Okay.
that. Yeah, no, I think we have done this
Looks
question.
like we
That's fine.
have.
We can move on to the next one. Okay, I just want to see what Gugu said here. So when I made my Gugu, in respect to what? In your final answer? I'm just looking at this. So when I make my x to the power of -4 positive, oh, I see. Yes, you would. You would still write dy over dx. But Gugu, don't bother with that. Okay, don't go and write it with positive exponents. You don't need to. I promise you, promise you, promise you, promise you. Okay, you can leave it with negative exponents. All right, and it's absolutely 100% perfectly correct. Okay, so it's these little things that can save us a bit of time. because we want a bit of extra time to go and have a look at the slightly more difficult questions. Okay, so now let's have a look at this question. Again, comes out of a past paper, NSC paper, obviously, end of year. And here it says to us, for a certain function f, the first derivative is given as f prime x equals 3x squared plus 8x minus 3. They want us to calculate the x coordinates of the stationary points of f, for which values of x is f concave down, sure. 9.3, determine the values of x, for which f is strictly increasing. And then they've asked us 9.4, the real reason we're doing this question, if it is given that f of x equals ax cubed plus bx squared plus cx plus d, and f of 0 equals negative 18, determine the equation of f. Right, so here they have given us the information about the graph of the first derivative of the cubic function. And as expected, it's a parabola. Okay, so when we want to do question 9.1, calculate the x coordinates of the stationary points, what do we need to do? What are we going to do in this case? Exactly, intercausal. Exactly. That's it. Okay, I'm going to let you guys do that. And then you can share your answers with Yolanda and I when you're done. All right, so you seem to know what to do with 9.1. That's great. Off you go. Okay, Joshua, thanks for sharing. Everybody else, just keep going. Joshua, if you want to go on with question 9.2, you're welcome to give that a try. I see some answers coming in here, Yolanda. A couple of people have got things that are a little bit different to the others.
Yeah,
So
I
there've
see the
been
difference.
a couple of mistakes. Not that you won't get any marks, Joshua, but they could penalize you. Okay. So I see Cheslin and Amatle have got the same answers. And Corzo's got the same answer. Gugu. Yeah, I'm just having a look, Gugu. Yes, 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 yes. Okay. Kalipa, Gugu, all correct. Okay. So again, you could have used the quadratic formula, or you could have factorized. We're going to put 3 there. We're going to put 1 there. We want plus 9 minus 1. Okay, so those answers were correct. So either x was equal to 1 over 3 or x was equal to -3. And that's what the majority of you said. Okay, it's all right, Joshua. No stress. Do you know where you went wrong? Okay, cool. As long as you know where you made your mistake, we're all good. Okay, lovely. Let's try 9.2. Thank you, Mamelo. Yes, you can use the quadratic formula. Absolutely, Cameron. So every time that you have to factorize, if it's nasty for you, then use the quadratic formula. If it means you're going to get it correct, you just have to show that you've subbed into it. All right, so I'm going to let you guys do 9.2 and 9.3 by yourselves as well. And again, you can share your answers with Yolanda and I, and we'll give you some feedback, and then we'll work through it as well, just to make sure that everything is correct. Sure, Chesla, not a problem. There's no graph in this particular case. You were only given the equation. So now you have to know how the graph of the first derivative is related to your cubic function. That's okay. No stress. It's difficult when you're going up and down, up and down. I know I also miss things sometimes, or whatever the case is. So, but yeah, unfortunately in this case, the graph was not sketched. Yes, I'm agreeing with you. Okay, now just be careful. A lot of you are saying what it's equal to, but the question says for which values of x of f is f concave down. So it's not concave down at the point of inflection. So just make sure you answer the question. You're solving for the x coordinates at the point of inflection correctly, but then make sure you answer the question. Okay. So far, Zegofatso, yours is correct. Okay, Gugu, think about the shape of your graph. What shape is going to, what is this parabola? Remember, it's a smiley face parabola, isn't it? So the cubic function, is it going to be concave down and then concave up, or concave up and then concave down? That's good. Well done, Gugu. Lovely. Okay, so I'm just going to work slowly behind you guys. Sorry, into causal. Just see your answers. Okay, now intercausal. You have got the right idea, but you can't say or equal to in this case. Why not? Tsegofatso, that's perfectly correct for 9.3. Okay, Gugu, I see you haven't done 9.3 yet. That's fine. Yes, Kalipa, you can use interval notation. That's not a problem. Sure. So, Unica, I hope I've said your name correctly. Which question is it that you want me to elaborate on? (9.2). Okay, and then I don't know how to pronounce Avhashoniko. I don't know how to. I'm sorry, I'm butchering your name. If you write your answer like this, just show me what you want to write, and then I can tell you whether it's correct or not. Okay, so Unica, let's just go through 9.2, right? Where they said for which values of x is f concave down, right? So the graph of the derivative, the turning point on the derivative, the x-coordinate at that turning point is the same as the x-coordinate at the point of concavity, at the point of inflection. All right, so if we want to know what this value of x is over here on the graph of the derivative, we have to use our x equals negative b over 2a. Okay, in order to work out what the x-coordinate at the turning point is. And the x-coordinate at the turning point on the parabola is the same as the x-coordinate at the point of inflection on the cubic. Okay, so that's why everybody was doing that. Okay, so here we're using x equals negative b over 2a. Then what they did is they worked out the x-coordinate at the point of inflection, and then they thought about the shape of the graph. So this particular graph is concave down and then concave up. Right, so it's going to be any value of x that's smaller than minus 4 over 3. Does that make more sense, Unica? Yes, Avash, if I pronounced your name correctly, that is correct. Ma'am, I use the second derivative. Am I still correct? Was that for 9.2? You use the second derivative. That's not a problem, Gugu. Absolutely. Absolutely. So that's the other way that we could do this in this particular case. All right, so we could have said f prime prime x, and then that would have been equal to 6x plus 8, make that equal to 0. And then you see you would have ended up with the same answer for x. And then you would have still need to say, therefore, where x is smaller than minus 4 over 3. Okay, so not a problem. Is that making sense, Joshua? Mamela, you also use a second derivative, no problem. Okay, so either of these two would have been correct in this case. Okay, I suppose, I mean, the way I did it over here, I suppose that just would have been a little bit faster, but honestly, it's absolutely fine that you use the second derivative. You probably find most of you use the second derivative rather than turning point formula. Okay, now, yes, with pleasure. Just take a screenshot of the question. Now let's talk about 9.3. So I don't know who it was. I don't think it was you, Mamelo. Hold on, who was it? Was it? Hang on a second. Can you use interval notation? You can. Intercausal. Okay, so it's intercausal. I just want to speak to here as well as the rest of you. Wow, Tsegofatso, so you've finished it already. You've just got your head down and working. Well done. Okay. Intercausal, they use the words, and everybody else, they use the words strictly increasing. Okay, so when they say increasing, and you include the x-coordinates at the turning points, they'll let you get away with it. But if they say strictly increasing, they're not going to let you get away with it. So you cannot include the coordinates at the turning points in this case. All right, so if we just go back and pop our turning points on here, obviously -3 would be that one over there, and 1/3 would be that one over there on the right-hand side. So where it was strictly increasing is going to be where the gradient is positive. So it has to be that part over there, and it has to be that part over there. So it has to be where x is smaller than -3, or where x is greater than 1/3, but not including. Okay, is everybody else happy with that? And Ntokozo, are you happy with that? Yes. Okay, so just be careful of the words strictly increasing. Okay. All right. And again, you can always write these inequalities using interval notation, Kalipa, if you want to. Okay, so 1 mark on that and 1 mark on that. Okay, so Tsegofatso, you already finished. You're just going to have to give us a second to catch you up here. We're not quite where you are yet. Let's have a look at question 9.4. Cool. Okay. Thanks, Tsegofatso. If it is further given that f of x equals ax cubed plus bx squared plus c plus d, and f of 0 equals -18, determine the equation of f. Okay, so how are we going to do this, guys? How are we going to work back to the equation of f if we've been given the equation of the first derivative? What do we do? Shame you've all gone quiet now. Do you want me to explain it to you? Okay, so there's a whole bunch of yes pleases coming through. All right. Ntokozo, it's just yes, that's true, Tsegofatso. That's absolutely right. Ntokozo, yes. Yes, you've got the right idea. Okay, so oh wow, well done, Gugu. Okay, all right. So just for those of us that are struggling with this, let me just explain it to you. So in 9.4, we kind of have to work going backwards. Remember, we were given f prime x is equal to 3x squared plus 8x minus 3. What we're going to do is we're going to take this and we're also going to derive it. All right, so we're going to say f prime x is, and now I'm going to say 3 times a will give me 3a, and then I'm applying my power rule and I'm taking 1 away from my exponent, plus 2bx plus c. Remember, as the others have said, well, this is Tsegofatso and can't remember who else. I think it was Gugu. All said, if f of 0 is equal to -18, that's them telling you which letter is 18. What does this mean over here? Good. Well done, everybody. So that means that d is equal to -18. They've told us that. They've given us the y-intercept. Beautiful. But now they're allowing us, what we've got here is a way for us to be able to work out what A and B and C are. So we have to do this by inspection. Okay, so we are looking at this term over here and we are comparing it to this one. They are equal to each other. Okay, so 3x squared is equal to 3ax squared. And because we've got x squareds on both sides, we can drop the x squareds and we can say, well, 3 must be equal to 3a. So therefore, a has to be equal to 1. Okay, so this is the inspection method. It's the only way that we can do this. All right, and then our second term there and our second term here are also equal to each other. So we've got 2bx is equal to 8x. Again, now that we've got the same variables, we can equate our coefficients. So that means that 2b is equal to 8. So b is equal to 4. And the last one here, we've got c there and -3 over here. So we can therefore conclude that c has to be equal to -3. Okay, and of course, if f of 0 equals -18, this means that d is -18. Thus, f of x has to be 1x cubed plus 4x squared minus 3x minus 18. Does that make sense to you all? Okay. All right. So Unica, Ayanda, Ntokozo, Kalipa, you all, Mamelo's happy. Joshua, you happy? Good. Good. Lovely. Amahle, oh, good. All right. So it's just a case of taking the first derivative of your function and then using inspection. Okay, once you have identified which terms are going to be the same based on their coefficients, you can then drop the coefficient and just work with drop the variable and work with the coefficients. Okay. Any last questions?
Can I run my poll while they ask their last question?
You can run the poll quickly.
Okay.
Okay, so please do answer the poll. Yes, go for it, Cheslin. What did you want to ask? You're welcome to unmute and speak if it's easier, Cheslin. Yes, they do. They do ask you derivatives for optimization. They do, absolutely. So yes, absolutely. So for example, this weekend at boot camp, just before you guys go, let me just show you this question. Those of you that were with us at boot camp, oh, hang on, it wouldn't have been that one. It would have been here. Because I'm going to take your question now. Oh, hang on a second. I think it was actually what I was doing. Sorry, it wasn't boot camp. It was with these guys. Okay, so if you have a look at this, for example, okay, this is what I was doing with the other class. right? They've given us a box. It's got a volume of 300 meters cubed. The length of one side of the base is X. The height of the tank is H meters. So the first thing that they wanted us to do was find H in terms of X. And then they wanted us to show that the total surface area of the box is this. And now, hence, determine the value of X that will result in a maximum total surface area. So if you have a look in 10.3, I had to derive A of X. Okay, so very definitely you have to derive before you can solve for your X value. Okay. Yeah. Sorry, Gugu. It's so difficult with just this little bit of time left. If you want to, Gugu, you're more than welcome. If you want to take some screenshots here, you're very welcome to take some screenshots of these particular questions, because this is not something that you guys would have seen before. Okay. And you know what, Gugu, at the end of the day, this section is not worth as many marks as the other one. All right, just zoom out a little bit. Okay. Just make that a little bit smaller. Let's just make that a little bit smaller as well. Okay. So there you go. You can, oopsie. Let's just try and move this down a little bit. Oh, that's why it's being it's being a pain in the backside, but you can screenshot that if you'd like. Yeah. Okay. The graphs are more important than the optimization. The optimization is a much smaller section. So that's why I decided to, but yes, Chesley, in terms of displacement, velocity, and acceleration, absolutely they do. So this is another question that I did with the other class. If you have a look at this one. So a family travels through a mountain pass on their way to Cape Town. The car's height in meters after sea level, after T minutes is given as this. The journey through the pass lasts 8 minutes. So how high is the car above sea level when the family begin their journey through the pass? Calculate the rate at which the height of the car was changing at exactly 4 minutes into the journey through the pass. And then the last question, after how many minutes into the journey will the rate of change of height with respect to time be a minimum? Okay, so there you go, Cheslin. All right, so
I'm gonna just pop up to the other class.
That's fine. You go to the other class and I'll just finish off with these guys. So here in this particular question, they were asking us about the first and the second derivatives. Okay, so yes, they very definitely can do that to you as well. Okay, I think this is quite nice. Here, everything's all on the screen. So if you want to take a screenshot of this one as well, you can try it and then you can see if you get the same answers that I've written down here as well. Okay. But yeah, I mean, look, this is only out of 8. Whereas if we take one of our previous questions, I mean, just finding the equation of the function is 5 marks. So our graph is a little bit more important than it's worth more than the questions on optimization. Okay.